In this video, we're going to talk about creating sinusoidal graphs. So really learning about all the graphs of sinusoidal things and how to create them really led to this, where you have a situation, you want to create a graph that models a scenario. All right, so make sure you're just comfortable with all those things we've learned about with our sinusoidal graphs. All right, make sure you can graph them, you know what midline, amplitude, period, all that stuff is. All right, so now we're just trying to go the other way. We started with a function and we graphed it. Now we're just trying to go the other way. We're trying to create a function that looks like this. All right, so here's the general strategy. All right, the first thing we're going to do is figure out the period for our sinusoidal graph, and we go backwards. The b value. So normally we were going forward 2 pi over b, but we can go backwards if we move these things around. We also get the b value that's going to go into our equation is 2 pi over the period. If we identify the highest and lowest values in the scenario, all right, that'll give us the high value, the low value. The midline has to be right in the middle. So we're actually going to average these to figure out the midline. Once we know the midline, the amplitude is just the distance from the middle to the top. So we can just subtract those to get the amplitude. And then we might, sometimes it's not important, sometimes it is important if we use sine or cosine. So sine, if we have our midline, sine starts on the midline and kind of goes up and back down. Cosine starts at an extreme value, high, and goes down. All right, so kind of important depending on if it matters where you start, or it'll matter if it's sine or cosine. All right, it's always kind of confusing when I talk about the strategy without an example, so let's do an example. All right, the average high temperature in Phoenix oscillates between 80 degrees and 120 degrees over the course of the year. Create a sinusoidal function that models the average high temperature in Phoenix X days after the hottest day. All right, so first thing we do is identify what is the period. How often is this graph or situation going to repeat? Well, our unit is days. How many days is it going to take for the temperature cycle to repeat? Well, the temperature cycle repeats every year. Right? In the winter it's cold, in the summer it's hot, and that year has 365 days. So if our period is 365, the b value, which is actually going to go into our expression, is 2 pi over that value. And we can't really simplify this at all. We just have to leave it like that. So it's okay. It's ugly. You're just going to leave it like that. All right. So we found our b value. Next, we have to find our d value, our midline. And the way we do that is we find the high value. The highest value in our scenario is 120. The lowest value in our scenario is 80. And the midline is the middle of those two. So I add them together and divide by the number of things. This is the average. And we get 100. So the middle of our scenario is 100. And the last thing we do is figure out our amplitude. The amplitude is just the distance, the height of the wave. So we take our high value and we subtract our midline. That'll give us the height of the wave. All right, one common mistake is you would subtract these two, but that gives you both waves. All right, so you could subtract those two and divide by 2, but the easier way is just take the high, subtract the midline, you get your amplitude. And the final thing is, does sine or cosine matter for this one? It actually does, because they want us to know after the hottest day of the year. So we want our equation to start at this high point. And if we start at the high point and kind of go down from there, that's our cosine graph. Sine graph starts in the middle, whatever, not the highest point. So our final answer is going to be temperature is amplitude goes first, 20. Because we want to start at the hottest day, it's cosine. Our b value goes in the parentheses with the x. And our midline goes last. All right. So these are the exact same steps you're going to do every single time. There's nothing too crazy. Sometimes the hardest part is kind of identifying your period, how often it's repeating. Pretty much other than that, it's averaging 2 numbers, subtracting 2 numbers to get the other values. All right, so here's a really common one for sinusoidal graphs is you're on a Ferris wheel. All right, so let's draw a picture. We have this Ferris wheel. It's on this platform that's 3 feet high. All right, and you're going to ride this Ferris wheel around. The radius of the Ferris wheel is 15 feet. So from the center to the outside is 15 feet. And the Ferris wheel completes a full rotation every 6 minutes. I create a sinusoidal function that models X minutes after they get on. Okay, so let's go through. First thing we know is we want to figure out the period. How often is this scenario repeating? Well, it's when I go all the way around I'm going to start being in the same place, and that's 6 minutes. So our period is 6. So the b value is 2 pi over 6, which is pi over 3. All right, so that's the b value that's going to go in. The most common mistake for this is just putting in 6 into your function, but there's this little formula you have to do to work backwards from the period to the actual value in the function. Next is the midline. So to find the midline, I first need to identify the highest value and the lowest. In this scenario, the lowest is actually the easier one to calculate. It's right here when you get on to the Ferris wheel. That's your lowest height, and that's when you're 3 feet off the ground. The highest point is when you're up here at the top. So to get to the middle, we know the radius is 15. To get to the top, you have to do another 15. So the highest point is going to be 33. Oops. All right, because it's 30 feet all the way across the Ferris wheel plus that little 3 feet platform that the Ferris wheel is on. And our midline is the average of the high and low. Equals 18. All right, so our midline is 18. Then our amplitude is the height of the wave. We take the highest value and we subtract off the midline. And that gives us 15. All right, so now we can start to put it all together. Our height is 15 for the amplitude. I will talk about if we're going to use sine or cosine in a second. Pi over 3 is the b value next to the x plus 18. All right, so now we need to figure out, is sine or cosine more appropriate? All right, when we're looking at this scenario, it's x minutes after they get on. So we're actually starting here at the lowest value. All right, so which one's going to be the right expression? All right. We have cosine, which starts at the top and goes down. We have sine that starts in the middle and kind of goes up like that. Neither one of these starts at the lowest value. So how can we make something start at the lowest value? If we take cosine and that starts at the highest value and flip it, so it does this. Now cosine starts at the lowest value. The only way we need to do that is we just need to make it negative cosine. All right, so cosine is going to be more right for most of these ones. If I want to start the highest value, I use positive cosine. If I want to start at the lowest value, is negative cosine because it flips this high value down to that low value. These are the numbers are more important, but this is technically part of the problem as well. All right, another example, I'm going to load quicker because the video is starting to get a little long. Child's on a seesaw. They start on the ground and go up to 6 feet. It takes them 10 seconds to get back to the ground. All right, so period. How often is it repeating? They're starting on the ground when they're at the top of the... Yeah, it takes them 10 seconds. All right, so the period is 2 pi over 10. Or it's not the period, the b. The period is 10. The b value that's going to my equation is pi over 5. The high value for this scenario is when they're at the top of the seesaw. They're 6 feet off the ground. And the low value is when they're on the ground, 0. Which means my midline is 6 plus 0 over 2. 6 over 2 is 3. And my amplitude is the high value minus the midline, which is also 3. All right, so my final answer, my height, is so x seconds after they get on the seesaw. When you're getting on the seesaw, you're getting on at the bottom, so you're getting in the lowest point, and that's a negative cosine graph. So it's negative cosine, amplitude goes at the front, b goes in the middle, midline goes last. Okay, so that's the height of the child, x seconds after they get on. And here's one for you to try on your own. All right. Water park, making wave machines. All right, try this one, figure out your values and the thing. All right, I'll show you the answer in 3, 2, 1. All right, and this is a solution I came up with. So the period, it makes a new wave every 30 seconds. So you do 2 pi over 30, get pi over 15. That's your b value. It's making waves that are 10 feet high. And then when there's no wave, it's 0 feet high. All right, so my midline is 5. I take my midline and subtract it from the high point, and I also get an amplitude of 5. And then this was a little ambiguous. The last wave was created. I'm thinking about that as the last time the crest of the wave was made. You could also think about it as the last time there was no wave, so you would put a negative sign in front of this. This one's a little ambiguous, so negative or positive I think would make sense for the scenario. All right, so quick summary. The most common mistake is getting the wrong value in the parentheses. Remember, it's not just the period. It's 2 pi divided by the period. That's the b value that goes in those parentheses. All right, the midline is the average of the high and low value. And the amplitude is that high value minus the midline. That'll give you the height of the wave. All right, so put all that together and you can create your sinusoidal functions.